So today's going to be a pretty quick video. I just want to go over two theorems that we haven't really looked at too much yet, and they're kind of related to this ratio and proportion work that we've been doing. So the first one that we're looking at is on page 18 of this packet, and it says the triangle proportionality theorem. And what it says is if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. So what does that mean? We got a picture right here that represents what we're actually talking about. So over here I'm going to say if DE is parallel to AC, as they show in the picture with my little symbols showing parallelness, then I'm going to say BD, the ratio of BD to DA, so BD to DA is equal to the ratio of BE to EC. And that's all it says. And then the converse of that theorem, now again, we talked about converses of theorems a little bit when we looked at parallel lines. The converse is, if I've got that proportion, like that, then it tells me that the lines are parallel. So let's take a look at what this actually means. I'm only going to do a couple examples because they all kind of work the same way. So for example, in number 1 here, I'm going to take 14 and 12. And I'm going to say, and the reason I'm doing this is because I got my parallel lines right there, so my ratio of 14 to 12 should be in the same proportion, or should be proportional, I should say, to x over 15. So I do my cross multiplication like we've been doing, and x equals 17.5. Just like that. So not too difficult. So now I'll do one more example with you. I'm looking at number 2 now. So again, I'm looking to see, I've got my parallel lines right here, so I'm going to say if I've got 18 to x, that should be equal to 21 to 56. I'm going to do that math out. 1008, and I get the x equals 48. Now, a question that we got last time, how do I really know what to put in proportion with each other? In this specific instance, if I'm using this theorem, I'm looking at the ratio between the segments that are made from this parallel line, these parallel lines coming through. So for this, to use this theorem and use this proportion, the things that are on the same side are going to be in the same ratio like that, which is a little bit different than what we talked about with similar triangles and making those ratios. But in this case, if they're on the same side, they're in the same ratio. 18 to x is the same as 21 to 56. And obviously, if I look here, my smaller segment, if I put my first smaller segment on top, I want to put my first smaller segment as the numerator and my second ratio as well. So why don't you guys try 3 and 4. And we'll talk about those in next class. And once you're done with that, let's flip the page. And I want to talk about this right here, proportional parts and lines. That's our other little theorem that we're going to finish today out with. So this says if 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionally. So here I've got my 3 parallel lines, and right here I've got my 2 transversals. Let's see if I can get that. There we go. So what this is saying, and we're going to kind of do what we did in the last example, if I've got AB parallel to CD and also parallel to EF, then I know that AC, the ratio of AC to CE, which again, this is AC right here, and this is CE right here, is equal to the ratio of BD to DF. So we're going to do the same thing that we did, pretty much the same thing that we did over here. We're just dealing with some more lines in this case. And we're not really dealing with a triangle. We're dealing with just parallel lines. So for example, in number 10, I'm going to set my proportion up pretty much the same way. I've got 45 to 18. They are both part of the same transversal, equals the ratio of 52 to x, also part of the other transversal there. And then I do the same thing. I cross multiply. 45x equals 936, and x equals 20.8. So not too bad. Let's take a look at one more difficult case, number 14. My setup is exactly the same. I've got my 3 parallel lines here. I've got my 2 transversals here. So my setup is going to be 24 to 18 equals 3x plus 1 over 12. Not too bad. Now what might help you a little bit here is actually reducing this 24 over 18. You do not have to by any means, but I think it will help you, because I can reduce that down to be 4 over 3, so then my multiplication isn't such large numbers. That will leave me with a 48 equals 3 times 3x plus 1, which turns into 48 equals 9x plus 3. Subtract my 3 to get 45 equals 9x, and divide out that 9, and that equals 5. So not too bad, I do not believe. So why don't you try 13 and 15, and then we'll talk about those next class. And that is all we are going to do for today. We'll chat more about it next time.